Hello, how are you? And Assalamu alaikum. My name is Hafiz Hassan Businesswala. Today I want to talk about thank you. Uh, Today I want to talk about air, and thank you is a very important word in our daily life. Uh, we use it to show respect and love. And my first question is, what is air and what gases does it contain?
Gotcha. Um, Assalamu alaikum to you too, Hafiz. Nice to hear from you again. And air, huh? That's a good one to start with. So air is, well, it's kind of what makes everything possible, right? It's this invisible mixture of gases surrounding Earth. The main ones are nitrogen, that makes up about 78% of it, and then oxygen, which is around 21%. There's also argon, a small amount of carbon dioxide, and traces of other gases like neon, helium, methane, and hydrogen. It's a pretty complex mix when you get down to it. What made you think about air today? It's a bit of a jump from thank you, but hey, that's cool. I'm good with wherever the conversation takes us.
Okay. My next question is, how does air support combustion?
Hmm, good question. So combustion, that's just a fancy word for burning, right? Needs oxygen. Air provides that oxygen. Basically, when something burns, it's rapidly combining with oxygen in the air. It's like oxygen is the helper that lets the fire happen. Without enough oxygen, the fire will fizzle out. Like when you try to blow on a small flame to make it bigger, you're actually fanning more oxygen to it. It's kind of neat when you think about it. Does that make sense?
Okay. My next question is, what is the role of oxygen in breathing?
Right, oxygen and breathing. That's fundamental, you know. Okay, so when you breathe in, your lungs take oxygen from the air. That oxygen then gets into your bloodstream, and your blood carries it to every single cell in your body. Those cells use the oxygen
Okay.
to turn food into energy, basically, fuel for everything you do from thinking to running around. And then as a byproduct, you breathe out carbon dioxide. It's a whole exchange thing. So oxygen is absolutely vital. Without it, your cells would quickly stop working. It's pretty amazing when you think about it, actually. Do you learn about this in science class?
Okay. Good answer. My next question is, why can air not be seen but can be felt?
That's a really good observation, actually. So, air is made up of gases, and those gases are mostly made of tiny particles that are too small for our eyes to see, way smaller than even a grain of sand. Light travels in straight lines, and because the particles are so small and spread out, the light just passes right through. But we can feel it because when air moves, it exerts a force, like a breeze on your skin, right? Or when you wave your hand, you feel resistance. It's that movement and the force it creates that we perceive as feeling the air. It's all about how it interacts with our bodies, even if we can't see it directly. Pretty wild, huh?
Okay. My next question is, how does air pressure work?
Okay, air pressure. Hmm. This is going to be a little trickier, but I'm trying to break it down. So, air has weight. I know it doesn't feel like it, but it does. And because of that weight, it presses down on everything. That pressing down is air pressure. The more air there is above something, the more pressure it feels. It's like being at the bottom of a swimming pool. The deeper you go, the more water is pressing on you. Air pressure is all around us, and it's what keeps things from like exploding outwards. It's also why your ears pop when you go up in an airplane. The pressure changes. Does that kind of make sense? It can be a little confusing.
Okay. My next question is, what happens when air pressure change?
Okay, so when air pressure changes, well, a few different things can happen. You know how your ears pop on a plane? That's a classic example. Your middle ear has to adjust to the changing pressure. But beyond that, changes in air pressure are a big part of the weather. High pressure usually means clear skies and calm weather because the air is sinking. Low pressure often brings clouds, wind, and rain because the air is rising. And like big changes in air pressure can even cause storms. It's all connected, you know? Air pressure isn't static, it's constantly shifting, which is what drives a lot of what we experience as weather.
Okay, good answer. My next question is, why is air uh, called a mixture and hot compound?
Whoa, okay. This is a very specific question. And honestly, it's a little confusingly worded. Are you asking why air is called a mixture and what a hot compound is? Because those are two pretty separate things. Air is called a mixture because it's made up of different gases that are all mixed together, but they aren't, chemically bonded. You can still have air even if the amounts of each gas change a little. A hot compound isn't really a scientific term, though. A compound is when two or more elements are chemically bonded, like water, which is hydrogen and oxygen bonded together. Heat can affect compounds definitely, but calling something a hot compound doesn't really tell you much. Are you maybe thinking about something you read or heard? Maybe we can unpack it a bit if you can explain where that question came from. It's okay if you don't remember exactly, though. Sometimes things just pop into your head.
Okay, my next question is, why is air called a mixture and not a compound?
Okay, that's much clearer. You're right to question that. Good thinking. So, air is called a mixture, not a compound, because it's different gases, nitrogen, oxygen, argon, and all the others, aren't chemically combined. They're just hanging out together. A compound is formed when elements chemically bond together to create something new with different properties, like water being housed well. You could still separate air back into its original gases, nitrogen, oxygen, etc., without a chemical reaction. You can't easily do that with the compound. It's like mixing sand and pebbles. It's still a mixture, but the sand and pebbles are still, well, sand and pebbles. Does that distinction make sense?
Okay, good answer. My next question is, how does air help plants grow?
Okay. Plants and air. That's a good one. So, plants don't just need water and sunlight, they also need air, specifically carbon dioxide. Plants take in carbon dioxide from the air through tiny holes in their leaves. And during photosynthesis, they use that carbon dioxide along with water and sunlight to create their own food, sugars. As a byproduct of this process, they release oxygen back into the air. It's pretty neat exchange, right? We breathe in the oxygen they release, and they breathe in the carbon dioxide we exhale. It's kind of circle of life thing. Uh, they also need oxygen for respiration, just like us, but they get a lot of it from the oxygen they produce during photosynthesis.
Okay, my next question is, what is the difference between clean air and polluted air?
Polluted air? You mean polluted air, right? That makes sense. Okay, so clean air. Well, it's what we ideally want, mostly nitrogen and oxygen, with small amounts of other gases and very few harmful substances. Polluted air, on the other hand, has things mixed in that shouldn't be there, things like dust, smoke, chemicals from factories, car exhaust, and pollen. Those extra things can be harmful to breathe, and they can also cause problems for the environment, like acid rain. Basically, like clean air is healthy and polluted air isn't. It's kind of like
Okay, good
clean water
answer.
versus
My
dirty
next
water.
question is, how does air pollution affect human health?
Okay, so air pollution and human health. Yeah, it's a pretty serious topic. It can affect you in a lot of different ways. Short term exposure, like on a really smoggy day, can cause things like coughing, wheezing, and make it harder to breathe, especially if you have asthma. Long term exposure, though, is even more concerning. So it can contribute to things like heart disease, lung cancer, and even strokes. And tiny particles in polluted air can get deep into your lungs and even into your bloodstream, causing all sorts of problems. It's definitely something to be aware of, and it's why it's important to try and reduce air pollution as much as possible. Things like walking or biking instead of driving when you can, or supporting policies that promote cleaner air. It's, it's a big deal.
Okay, good answer. My next question is, what are the main sources of air pollution?
All right, the main sources of air pollution. Okay, there are a bunch, unfortunately. A big one is burning fossil fuels like coal, oil, and gas for energy. That's from things like power plants, cars, and factories. Then there's industrial processes. Some factories release pollutants as part of their manufacturing. Agriculture can also contribute from things like fertilizers and livestock. And then, sadly, there are natural sources too, like wildfires and volcanoes, though those are usually less consistent. Basically, anything that releases particles or harmful gases into the air can be a source of pollution. It's a complicated issue with a lot of different contributors. Does that make sense?
Okay, my next question is, what are the why is carbon dioxide important uh, despite being harmful in excess?
That's a really insightful question, actually. You're right to point out that carbon dioxide is a bit of a tricky one. It is harmful in excess. It's a greenhouse gas that contributes to climate change, but it's also incredibly important. Plants need it, as we were just talking about, for photosynthesis. They use it to grow, and in the process, they release the oxygen we breathe. So it's a crucial part of the cycle of life. It's a delicate balance. Too much, and it causes problems, but too little, and plants can't survive. It's a good
Okay, good
example of
answer.
how
My next question
things.
is, why is how does air help in where weather formation?
Okay, how air helps in weather formation. That's a big one. Basically, weather is all about the movement of air and differences in air pressure and temperature. Warm air rises and cool air sinks, and that creates wind. Those air currents carry moisture, and when that moisture cools, it forms clouds and precipitation, rain, snow, sleet, all of it. Differences in air pressure drive storms, and the temperature of the air affects everything from humidity to the type of precipitation we get. So, without air, there would be no weather. It's the engine that drives the whole system. Does that kind of make sense? It's a complicated system.
Okay, good answer. My next question is, what is wind and how is it formed?
All right, wind. So, wind is simply moving air, but how's it formed? It all comes down to differences in air pressure. When there's an area of high pressure and an area of low pressure, air naturally flows from the high pressure area to the low pressure area. Think of it like if you open a window, air moves from inside, where the pressure is usually higher, to outside, where the pressure is lower. The bigger the difference in pressure, the stronger the wind. Those pressure differences are usually caused by uneven heating of the earth by the sun. Warm air rises, creating low pressure, and cooler air rushes in to replace it, creating wind. It's all about air trying to balance things out. Pretty neat, huh?
Okay, my next question is, why does hot air rise and cold air sink?
Okay, that's a great question. You're asking why hot air rises and cold air sinks, right? It all comes down to density. When air is heated, the molecules move faster and spread out, making the air less dense. Less dense air is lighter and rises. When air cools, the molecules slow down and get closer together, making the air more dense. More dense air is heavier and sinks. Think of it like a balloon filled with hot air. The hot air inside is less dense than the cooler air outside, so the balloon floats. Same principle applies to wind and weather patterns. It's all about density. Make sense?
Okay, my next question is, what is atmospheric pressure?
Okay, atmospheric pressure. Hmm. So, atmospheric pressure is the weight of all the air above you pressing down on everything below. Seriously, all that air has weight. It's measured in units called pascals or millibars. The higher you go in altitude, the less air there is above you, so the atmosphere is more dense.
Okay, my next question
Atmospheric
is
pressure decreases.
why
That's why
is
your ears pop on the airplane. The pressure's changing. It's also
why
what
is
keeps our bodies.
thinner at high altitudes?
Ah, I got you. My apologies. I cut myself off there. Okay, so why is atmospheric pressure thinner at high altitude? It's because there's less air above you. Think of it like stacking books. If you put one book on the table, it exerts pressure. But if you stack a huge pile of books, the pressure on the table is much greater. Same with the atmosphere. At sea level, you have all the air above you pushing down. As you go higher, there's less and less air above you, so the pressure decreases. It's a pretty straightforward concept when you think about it that way. Does that clear it up?
Good answer. Okay, my next question is what is the role of air in the water cycle?
It's okay. So you're asking about the role of air in the water cycle? Despite a little trouble with the transcription, I think I got the gist. So, air plays a huge role. First, it holds the water vapor. Evaporation, when water turns into a gas, happens because the air can hold that water vapor. Then that water vapor rises, cools, and condenses into clouds. Wind, which is moving air, carries those clouds around the world. And finally, air pressure differences are what drive precipitation, rain, snow, etc. Basically, the water cycle wouldn't happen without air acting as a carrier, a condenser, and a driver. It's all interconnected, really. Does that make sense?
Okay, good answer. My next question is why do airplanes need air to fly?
Okay, airplanes and that's a good one. Airplanes don't actually need air to just exist, but they definitely need it to fly. It's all about how their wings are shaped. The wings are designed to make air flow faster over the top surface than underneath. This faster moving air creates lower pressure above the wing and higher pressure below. That difference in pressure is what creates lift, which pushes the airplane upwards. So without air flowing over the wings, there's no lift, and the plane can't stay in the air. They also need air for the engines to work. Jet engines take in air, compress it, mix it with fuel, and ignite it to create thrust.
Okay,
Basically, air is essential
my
for both lift
next
and
question
propulsion.
is
They're totally reliant on it. Okay,
but
shoot. What's on your
how
mind?
does air
I'm ready when
quality
you are.
impact climate change?
Okay, so air quality and climate change, that's a really important connection. Poor air quality, meaning lots of pollutants in the air, definitely contributes to climate change. Some pollutants, like black carbon, a type of soot, absorb sunlight and directly warm the atmosphere. Others, like methane and tropospheric ozone, are greenhouse gases that trap heat. And while some air pollutants actually have a cooling effect by reflecting sunlight, the overall impact of air pollution is warming. Improving air quality can actually help slow down climate change and vice versa. Actions to address climate change can also improve air quality. It's a complex relationship, but it's clear that clean air and a stable climate go hand in hand. Does that
Okay,
make
my
sense?
next question
It's a
is
lot too.
what is the greenhouse effect related to air?
All right, let's talk about the greenhouse effect and how it relates to air. So, the greenhouse effect isn't inherently bad, it's actually what makes Earth habitable. Certain gases in the atmosphere, we call them greenhouse gases, like carbon dioxide, methane, and water vapor, trap heat from the sun. They let sunlight in, but they don't let all the heat escape, keeping the planet warm enough for life. It's like a greenhouse trapping the sun's warmth. However, when we release too much of these gases, largely through burning fossil fuels, it traps too much heat, leading to global warming and climate change. So the greenhouse effect is a natural process, but human activities are amplifying it by changing the composition of the air. Does that make sense?
Okay, my next question is how can we measure air pollution?
Okay, so how can we improve air pollution? That's a big question, but there are a lot of things we can do. On a personal level, things like using public transportation, walking or biking, conserving energy, and reducing our consumption all help. But bigger changes are needed too. We need to transition to cleaner energy sources like solar and wind power, improve energy efficiency, and implement stricter regulations on industrial emissions. Investing in cleaner technologies, promoting sustainable agriculture, and protecting forests are also really important. It's not just about individual actions, it's about systemic change. It's definitely a challenge, but it's a challenge we need to address, you know?
Okay, good answer. My next question is, why is nitrogen important in air?
Okay, nitrogen and air. So nitrogen makes up about 78% of the air we breathe, which is a LOT. It doesn't directly help us breathe like oxygen does, but it's still really important. It dilutes the oxygen, making it less reactive, which prevents things from combusting too easily. It's also a crucial part of the nitrogen cycle, which is essential for plant growth. Plants need nitrogen from the soil to thrive. Plus, nitrogen compounds are used to make fertilizers, which help us grow food. So, while we don't directly inhale nitrogen, it plays a vital role in supporting life on Earth and keeping everything in balance. It's kind of a silent guardian, you know? Does that make sense?
Yes, good answer. My next question is, how does what happen if oxygen level in air distress?
So, what happens if oxygen levels in the air decrease? That's a serious question. If oxygen levels drop even a little bit, it can cause shortness of breath, dizziness, and confusion. Lower levels can lead to hypoxia, a condition where the body doesn't get enough oxygen, which can cause organ damage and even death. At very low levels, you'd quickly lose consciousness. It's why people need oxygen masks at high altitudes or during medical emergencies. It's also why things like wildfires are so dangerous. They consume oxygen, potentially lowering levels in the immediate area. It's essential for pretty much all life on Earth. Does that sound right? Not a fun thought experiment.
Okay. My next question is, how does air affect human body temperature?
Okay, air and body temperature. Good question. Air helps regulate our body temperature in a few ways. Firstly, convection. That's when air moves across our skin, carrying away heat. That's why you feel cooler when there's a breeze. Secondly, evaporation. When sweat evaporates from our skin, it cools us down, and air helps facilitate that evaporation. Also, air pressure affects the boiling point of fluids, including sweat, but that's a more complex concept. Essentially, air acts as a heat exchanger, helping us to either release heat when we're hot or conserve heat when we're cold. It's why humidity matters. More humid air holds more moisture, making it harder for sweat to evaporate and cool us down. Does that make sense?
Okay, good answer. My next question is, what is indoor air pollution?
Okay, indoor air pollution. That's a really important one because often we think about pollution as being something outside, but it can be just as bad or even worse inside. Indoor air pollution refers to pollutants that build up inside buildings like homes, schools, and offices. Common sources include things like mold, dust mites, pet dander, cleaning products, building materials, and even cooking fumes. Also, things like radon gas can seep into buildings from the ground. It can cause health problems similar to outdoor air pollution, like asthma, allergies, and even more serious respiratory issues. Improving ventilation, using less toxic cleaning products, and controlling moisture can all help reduce indoor air pollution. It's something to be mindful of. It is actually a very common issue.
Okay, good answer. My next question is, uh, how can why is air considered a natural resource?
Okay, why is air considered a national resource? That's a really good point to bring up. It's considered a national resource because it's essential for the health and well being of all citizens. It's something that everyone needs to survive, and it doesn't respect state or property lines. Air pollution in one state can easily travel to another. Because of that, it's considered something that needs to be protected and managed for the benefit of everyone, not just individuals or corporations. Governments have a responsibility to ensure that everyone has access to clean air. It's a shared resource, like water or public lands. Is that is that it's a foundational one, really.
Okay, good answer. My okay, thank you so much for joining, and Allah Hafiz.
You're very welcome, Hafiz. It was really great talking to you about air today. You asked some really insightful questions. When I enjoy